All right, so I think this is recording. Let's take a look at these absolute value inequalities and see if we can solve them. In number 7, we've got two terms on the left-hand side. We need to get the term that has the absolute value by itself and actually eventually get the absolute value by itself. So I'm going to start out by adding positive 10 to each side of this inequality. So on the left-hand side, I'll have 8 times the absolute value of negative 10x. And when I add 10 to this side, 70 plus 10 is 80. So now I'm going to divide both sides by a positive 8, and I have the absolute value of negative 10 times x is less than what, 10. And the arrow is pointing towards the absolute value, so I know it's going to be the center portion of the number line that represents my solution set. I know I can write this as a compound inequality by saying that the solution set, this negative 10x, represents a number that's between negative 10 and positive 10. And this time I have to be careful because when I divide every term, when I divide all these sides by a negative 10, the arrows are going to change direction. So a negative 10 divided by a negative 10 is positive 1. And since I divided by a negative number, I have to change the direction of that inequality. And a negative 10 divided by a negative 10 is 1, so I have 1x. Here I have to change the direction of the inequality, and a positive 10 divided by a negative 10 is negative 1. Now, I like to have the arrows all pointing to the left. It helps me match this up when I graph it on the real number line. So if I write this side as negative 1, the arrow is pointing towards negative 1. Well, it's still pointing towards negative 1. The arrow is pointing here towards x. It's still pointing towards x. But if I write this, this is logically equivalent to, let's say that I have a student in the class whose name is Bob, and you say that Mr. Unsinger is taller than Bob, or you could say the same thing by saying that Bob is shorter than Mr. Unsinger. So those are that logically equivalent, and that's kind of what I'm doing here, only with a compound inequality. Negative 1 is to the left of positive 1. I need to make a decision whether to shade this or not to shade it. Since they're strict inequalities, I don't have a less than or equal to on these, so I'm going to leave these hollow, and I'm going to shade these numbers that are strictly between these two. So I'm ready to write my final solution set and to write it in interval notation. So I exclude the endpoints, which means I use parentheses to indicate that, not brackets. I have the smaller number, comma, the larger number, and there's my solution set for this number 7. Now, recognize in context that this is a solution set, that this is not the coordinates of a point in two-dimensional space. The notation, that unfortunately in mathematics, this notation is the same as plotting points. So you have to know the context of what negative 1 comma positive 1 represents. Here it represents a range of values as opposed to, like I say, a point in two-dimensional space. I don't think I've mentioned that before in other videos. I just thought of it right now as I looked at it. All right, so let's take a look at number 8 and try to solve it. Our absolute value is not by itself, so I'm going to subtract 6 from both sides. So I have negative 4 times this absolute value of this expression is less than, and 4 minus 6 is a negative 2. Now I need to divide both sides by a negative 4, and when I do that, since I'm dividing by a negative number, the inequality, the arrow changes directions. And negative 2 divided by a negative 4 is 2/4, and 2 over 4 reduces to 1/2. So I know when I look at this that the arrow, the absolute value, or the inequality is pointing away from the absolute value. So I know that my solution set, it's going to shade in the tails, not in the center like it was with number 7. So I come over here and I drop the absolute value and write x divided by 8. I change the direction of the arrow, and I change the sign from 1/2 to positive 1/2 to negative 1/2. Then for my other inequality, I just simply drop the absolute values. So now I solve each one of these. I'm going to multiply both sides of this by positive 8. And so I have x is less than, well, positive 8 times the negative 1/2 is negative 4. And then over here, if I multiply both sides by 8, 1/2 times 8 is a positive 4. Let's sketch this on a number line. Negative 4 and positive 4 are our critical points, or if you want to refer to them as boundary points or endpoints. They kind of have different vocabulary, and different textbooks may refer to these endpoints, like I say, as an endpoint, as a boundary point, as a critical point. They all, like I say, I think I've been saying all of those as I'm doing these videos, so that you're hearing the vocabulary. X to the left less than negative 4, all the numbers that are to the left of negative 4. X greater than 4 on the number line are all these numbers to the right of positive 4. And so now we want to write this in interval notation. The arrow is shaded on the left, and that's representing negative infinity. And then here, the negative 4 is not shaded, so I have to have an open parenthesis, not a bracket. And then I have a union symbol because I'm in this interval, or see, this union symbol is the mathematical or when we're speaking in English. So or 4 to positive infinity. So here's my solution set for number 8. So don't be afraid to ask questions. Let me know if I've made any silly arithmetic errors, because I can edit these videos and help other people. Hope this helps, and I will talk to you later. Bye.